Right, so let's make these notes. So standard deviation. Okay, so when we do a standard deviation, we basically are looking at the validity of the mean. Okay, so when we do our statistics, we're always looking at ways of analysing the data, but we're also looking at, is it a valid way of analysing the data? So I can't stress enough one thing that students, they get to DP and they have to do these IAs and things like this in maths. One of the things they get wrong is the difference between what I've done is valid and what I've done is incorrect. Okay, something can be perfectly correct mathematically, but not a valid way of analysing that data. Okay, that's a bit different from using Pythagoras' theorem when you should have used trigonometry to do a triangle, for instance. That's just incorrect. But when we analyse statistics, you know that there are lots of ways to do it, and we can make lots of different statements about the same statistics, right? So quite often, well, I guess you've got it at the moment, haven't you? With like the politics, a lot of the facts checking. It's that idea, you kind of make a statement. It's a bit different because a lot of those are just lies, all right? But a lot of it could have been like based on the data being analysed in a certain way, this could be true, all right? But if you analyse it in a different way, it's incorrect, right? It's not true. So therefore, it's the validity of your statement. So when we would use the mean, for instance, to compare two sets of data, all right? I think we've already talked about the mean could, like, the mean of the boys' score could, for maths test, could be higher than the girls' score, but if the girls all scored close to the mean, but the boys were spread out, you might actually have a number of boys that were a lot worse than the girls, and a couple of boys that were a lot better, but, you know, in general, how would you then compare the two? You know, it's a difficult statement to make. So the standard deviations talk about the validity of the mean. So what we do is basically the standard deviation, it's got this symbol here. Right, it's a funny little O with a thing on it. Okay. Standard deviation is the mean distance of each point from the mean point. Doesn't make, well, it kind of sort of makes sense. I think when you've gone through and actually done the calculation, all right, make more sense. So the mean distance of each point from the mean. Okay. So one thing that we should consider at the end is what would be considered a large standard deviation. So obviously, if I said a large standard deviation to you, what would I be saying? So we have a large standard deviation here. We would be saying, yeah. So the larger the standard deviation, the larger the number we get, the more spread out the data is. So let's say that. So the larger the standard deviation, the more spread there is in the data. But I can't spell in the morning. Large or small is relative. So I can't say to you, if you have a standard deviation of 10, that's big. If you have a standard deviation of 1, that's small. exactly. Well, yeah, it depends on the data you're actually using. All right. So I quite often use the example of if you are measuring the distances between stars, okay? So let's say you're doing that calculation in physics or whatever, and let's say you then look at the error in, you could actually work out the actual distance. Let's say you worked out error, and your mean error was 10,000 million kilometers. Yeah? Is that a large error? 10,000 million?
Not really.
Not really. When you're talking distance between stars, that's actually quite a small distance, yeah? All right. However, if I was talking about error in the distances that you've estimated about how big the field is outside, and the error was 400 meters, that's a huge error, right? If you estimate the length of the field and you're out by 400 meters in general, you're not very good at estimating, okay? But 10,000 million kilometers in terms of galactic measurements, that's quite small. So this is what we say about large or small is relative. But if you're comparing data, if one is larger than the other and you're in the same context, you know the deal, right? So there's still an element of you having to make a judgment on it. All right, so let's have a look. So we're in the textbook. Basically then, I just want to go through the calculation. It's going to be quite simple for it. When you get further on, we do it all using your calculators and things. All right. So let's just run through. It says we've got some data here. Example 1, I'm on page 80. Okay. At a summer carnival, a small crowd of people are trying to guess the weight of a small goat. The first 9 people to guess the following weights in kilograms. Find the mean weight and find the standard deviation of the weights. Okay. So, should we go through this? I know the answer's in the book, but let's go through it. Yeah? Should we do this calculation? All right. So first of all, to do the standard deviation, we need to know the mean of these numbers. So what is it? You work it out. Actually confirm what's in the book, please. All right.
Can I use my phone as a calculator?
So what's the mean? How do we do it?
We add up all of them and then divide it by.
Okay. So just to add some notation, are you all happy if we say, so let's say these are our x values. So if I said to you, we're going to do the sum of x values, okay? What are the sum of the x values? Have you actually worked that out? Yeah, anyone done it? Have you confirmed it? What's in the book, just in case it's a mistake? 188.6. Yeah, okay. Then we're going to do, we've got to find the mean. So the mean value, you're happy with that notation, yeah? X with a bar, mean. Done that before? Do you remember I've said in our scatter plots, the mean point was x bar, y bar, yeah? So this means the mean of the x, the mean of the y. So the mean of the x is, well then we've got the sum of x divided by n, which is the number of points, yeah? So we've got 188.6 divided by 9, and you get? 20.96. Say again?
20.96.
20.96. All good with that? Okay, so that's the mean. X bar is 20.96. All right, so before we do any further calculations, just your general idea, is 20.96, mask on please, we're recording as well. Is 20.96 a good representative of everyone's guess or a bad one? What I do, I just want you to say, is it good or not?
Okay.
What's your opinion?
So, in my opinion, I'd say it's pretty bad because there's only one. It's more of a large deviation, because, well, at least relative to this question, they're all very spread out. There's only it's only
Okay, so the 20.96, if we look at the actual data, look, we've got a 20.4, but we don't have that many close to it. But if it's the weight of a goat, how far out is out? Because it's kilograms, right? So if you're 1 kilogram out on weighing someone, is that a big or a small?
It depends.
Relative,
So, like, it
quite
depends
small.
on the animal.
It's a goat.
Well, if it's a goat. Well, you said if you're weighing someone, it's 1 kilogram max.
Well, we're weighing a goat.
Alright, so if we're weighing a goat, probably considering it's a lighter animal, it doesn't weigh
So
as
1
much.
kilogram could be considered a big problem, or?
A big problem, at least for a goat.
Really like goat, then it's gonna be a big problem. You're considering
Yeah, but
Yeah,
like,
true.
but when you eat, like,
If I'm a kilogram out, all right, then it's up for discussion, isn't it, whether that's an issue or not? But I've got people that are, well, this one's 6 kilograms up. Yeah. Now, if I ask someone to estimate my weight and they added 6 kilograms on, I'm not going to be that impressed. Okay. But you get it, and then we've got up to 26, and we're down to 14. So we're 6 kilograms. Now again, it's all relative. What do you think? That's what I'm after. That's kind of, with all these things, we've got to consider is it an issue or not. But let's do the standard deviation now. So basically, what we're then saying is, each of these points, we're saying, what's the mean distance of each of these points from that figure? All right. So they've done it in a nice table. Okay. I'm just going to do it in a list. All right. So I'm going to do, right, 20.96 subtract 18.3.
it's negative 2.6.
No, it's not. That's why I did it. So you can't just read from the book. And then I'm going to do 20.96 subtract 21.6, not negative. Just 2.6. This one is negative 0.64. 20.96 subtract 22.2 is?
Negative 1.24.
And then 24.0, sorry. Oh, I've got to maintain I'm going to ask you why in a sec, by the way. Why did I make that change? 24.0 is?
negative 3.04.
Okay. 20.96 minus, is it 17.4? 14.9 is 6.06, and then what's it then? 26.7, 23.1. Is that right?
And you missed 20.0, 20.4.
20.4.
Yeah, you missed that one.
Now, what are the answers?
Negative
Negative.
5.7.
Negative
2.1. 2.14. And that one is 0.56.
Okay. Now, what I did is not necessarily what you would have done just in your head. If I said to you, how far are each point away from the line, from the mean, you would have just done them all as positives, right? So you might say, oh, I am 2.6 above, or I'm 2.6 under. But if I want to know the mean distance from a point, negatives don't really work if I have negatives and positives. Why not? So I want to know, I want to know a distance, and it doesn't really matter what direction I am. And if I add up all of those numbers to now find the mean distance, what am I doing? The positives and negatives will cancel out. So really, what I would do as a human being is just ignore the negatives, wouldn't I? Or this is why I did it while I was working. I wrote this one the other way around and put the larger one first. All right, but we haven't done that. I've given you positives and negatives. Now, if I add all those together, the positives and negatives will kind of cancel each other out, and the mean will end up basically being 0, which is not true. All right, the mean distance would be around 0. It's not true. The mean distance is going to be definitely above 0, right? So the problem comes with technology. Right? A computer or your calculator is stupid in that you have to tell it, ignore negatives. Alright? And in maths we need to generalize, so we have to kind of give a consistent approach. So basically I have done the mean value subtract the value. Okay? Always. The mean subtract the value. Now I don't know which way around in the book it's done, but it doesn't actually matter. So what we need then is a way of counteracting the fact that I could get negatives. Any ideas? Could. I could use an absolute value, would be one way of doing it. That's not the way we do it in standard deviation, but it would work. Yeah? Squaring. So if you have a look in the formula, have you seen the formula yet in the book? Yeah. They square it. Any ideas why?
And it cancels out the negative.
Because it cancels out the negative. Is the number the same? No. But the negative is no longer there anymore. But we would need to remember to do what afterwards?
Divide by 2.
Square root, not divide by 2. Definitely not divide by 2. So what we do is we actually take this value, which is the mean minus the value, and we square it, and the big part of that is to get rid of the negative. So what do we have as squares? I mean, you can read it from the table if you like. So 2.6 squared is
7.07. 0.4096. 9.2419. 0.31.
3.56 squared.
12.6.
6.06 squared.
36.724.
5.74 squared.
32.947.
947.
948.
48. 2.14 squared.
4.569.
56.
96.
96. And then 0.56 squared.
0.3136.
Okay. So what I'm actually going to do is find the mean of those squared values. Yeah. So let's add all them up. Okay. Because now, without the negatives, I've not got that problem. Do you understand why we've squared them? Yeah. To get rid of that problem. Because if I said to you, what's the mean of 2 and negative 2? The mean would be 0. Okay, and that's the problem. It's not going to be exactly 0, but too close to 0. If I wanted the distance, mean of a distance, and 1 is 2 above and 1 is 2 below, the mean distance from the point is 2, not 0. Okay, so that's where it is. So if I add all these together, all right, what I get then is the sum of the mean minus the point squared, which is 105.5024. Okay, so that's just added it up. And then we have to divide by the number of points still. Remember, we're just doing the mean of this.
Yeah.
All right, so divide by n, which is 9 in this case. So divide by 9, and what do I get?
3.4238.
And then finally, we need to
Turn it into grams.
square root that, okay, to undo the squaring. So we need to square root that, and we get,
Oh wait, well,
or have you already told me that?
it was already that.
So this is the thing, that's why I did it, I checked.
Yeah.
So the square root of it is actually the 3.4. 238. Okay. So we are now saying that the standard deviation is 3.4. So Cameron back. What does that mean in terms of goats and measuring? What would you say? No, Cameron?
That's the
Can we put it in terms of like just basic English? You can start with in general.
That's how.
that is
People are.
the mean.
Yes. Basically, that's what it means. In general, this group have been 3.4 kilograms from the mean, whether that's above or below. All right.
Yeah.
So, but remember, that's not 3.4 kilograms away from the actual answer. That's 3.4 kilograms away from the mean of their guesses. The mean could be completely wrong. All right, but that's not what I'm after. I'm after, is the mean a useful measure to represent that group? What would you say?
Yeah.
So the mean, what did we say, is 20.96,
96.
and the standard deviation is 3.4238 kilograms. So how could you, what would be another way of expressing that as is it good or not? So I would say, what is 3.4 as a percentage of the 20? Did you work that out? What we got? 3.4238 divided by 20.96 times 100, and you get
About 17.
So what's happening exactly with calculators and things? I'm in a maths classroom. I should have a sea of calculators in front of me. Press it all you like. All it tells me is you haven't got your batteries sorted. 16.3. So basically, now you might not ever see them ask you to do that calculation, but basically I'm out like they're 16.3% away from the mean in general, yeah? So what would you say, your opinion?
That they were all incorrect.
Well, we don't know that because we don't know what the actual...
Yeah.
That's the thing, isn't it? We cannot say they are incorrect. That's not what this is about. We're asking, is my mean a useful measure to represent that group? Is it a fair measure? Well, we don't know until we have
The weight of the
another
goat.
set of data to compare with.
The weight of the goat.
Now, this other group, their standard deviation was 1.3. So their mean was much more useful, yeah? So that's what that's what we're looking at. The standard deviation, remember, does not tell me whether the mean is correct in this situation. It tells me whether people are generally close to the mean or not. So all we're then saying is, right, if the boys' standard deviation for their math score is large and the girls are smaller, all you can say is the girls tend to be more closely related to the mean. So I can use the mean. The boys are really spread out away from their mean, so the mean is not a very good use for the boys. That's all we're looking at, alright? Does that make sense? Okay, awesome. It's not too difficult. So what are you going to do going forward? Right. I would suggest carry on. Oh. Am I on the wrong page? I am, right. So we've gone through this. So looking at practice 4. Okay. Should we go for problem solving? It's always good. Problem solving ones are good to do.